Stay to the end to see how time travel works.
At Manchester University, right, so the first years, the 18-year-olds. And the first thing we do in special relativity is talk about the fact that if you travel close to the speed of light, so if you had a spacecraft traveling close to the speed of light, then distances shrink from your perspective. So, and the one number I always have in my mind is at the Large Hadron Collider at CERN, the protons go around the ring, which is 27 kilometers in circumference, and they go around at 99.999999% the speed of light. So close to the speed of light. At that speed, distances shrink by a factor of 7,000. And so that ring is something like 4 meters in diameter to the protons.
Whoa.
So according to laws of physics, if you can build a spacecraft that goes very close to the speed of light, you can shrink the distance to the Andromeda Galaxy, and therefore the time it takes to get there by an arbitrary amount. Actually, the closer you get to the speed of light, the more you can shrink it. And so you can make those 2 million light years. You could traverse across that distance in principle in a minute, according to physics. However, the downside is that you couldn't come back to tell, if you came back to the Earth at that speed, to tell everybody what you'd found, at least 4 million years would have passed on the Earth.